So here is our introduction to algorithms course topic, arrays and lists. Array features. All elements in an array must be of the same type, all integers, all double, and etc. The elements of an array are contiguous in memory. Arrays support sequential access and random access. Subscript random access time complexity is O of 1, and array are the fast to read and difficult to insert and delete. Why are arrays numbered from 0 instead of 1 in most programming languages? From the memory model of array storage, the best definition of the subscript is offset. If A0 is offset by 0, then A of k is offset by k type size. If A0 is offset by 0, then AK is offset by k type size. However, if the array counts from 1, then we calculate the memory address of the array element A of k as A of k address equal to base address plus k minus 1 multiplied type size. Comparing the two formulas, it's not difficult to see that numbering from 1 increases the subtraction operation for each random access to the array element, which is an additional subtraction instruction for the CPU. Array is a very basic data structure and random access to array elements by subscript is a very basic programming operation. So efficiency optimization should be as extreme as possible. So to eliminate one subtraction, the array is numbered from 0 instead of 1. But I think the main reason is historical. The designers of C used 0 to start counting array subscripts, and subsequent high-level language have followed C's example. So they continue to use the habit of counting arrays from 0. The list, a linked list, is a data structure that is discontinuous in physical memory. Linked lists use pointers to concentrate a set of discrete chunks of memory. Linked list features. Each element of the linked list stores the address of the next element, thus making a series of random memory addresses strung together. Adding an element to a linked list is easy. Just put it into memory and store its address in the previous element. Linked lists only support sequential access. Linked lists are fast to insert and delete. Linked list queries are slow because they must be looked up one element at a time. Compared with arrays, linked list elements also store the addresses of other elements, which increase the memory overhead. Singly linked list. A list is called a singly linked list when each node of the list contains only one pointer field. A pointer to a singly linked list points to an empty address. Common terms. A header pointer, a pointer to the first node, which may be a header or a header element. A linked list can be without a header, but not without a header pointer. Header. Sometimes we have a node called a header that precedes the first element of a single list, the header element. The header data field can store no information or additional information such as the length of a linked list. And header element, the first node in the list that contains a valid element. Circular linked list. Circular linked list is a special single linked list, the tail pointer of a circular linked list to the head of the list, so that the rest of the list can be found from any node in the list. Circular linked lists are especially suitable when the data to be processed has a circular structure. Two-way linked list. Bidirectional lists support two directions, which with each node having not only a successor pointer next to the next node, but also a precursor pointer path to the previous node. Bidirectionally linked lists require two extra spaces to store the addresses of successors and precursors. So if you store the same amount of data, bidirectionally linked lists take up more memory than single linked lists. Also, two pointers are a waste of storage space. They can support bidirectional traversal, which also gives the flexibility of bidirectional linked list operations. Here's array and list in comparison. Here's we have columns array, lists, and rows length, memory consumption, and usage. First, length array. Arrays always have a fixed length. The length of an array cannot be changed. A new array must be always created with a copy of the previous values. Length and list. Lists can be resized dynamically. Memory consumption array. Arrays have a fixed length and the memory is contiguous. Generally speaking, arrays are more memory efficient than lists, unless the array is oversized. Memory consumption lists. Lists have a non-contiguous memory space, therefore the internal implementation of the list is more complex and needs additional structures that consume more memory. Usage. Usage and array. Arrays are pointer if the number of elements is known. In addition, due to the contiguous memory, elements can be quickly accessed via indexes. Usage and lists. Because lists can resize themselves automatically. They are particularly suitable for frequent add and remove operations, and can those also achieve a better memory performance than arrays under certain circumstance. And thank you.